Okay, so this is the last question from the final review. We want to find the maximum area if we have a rectangle, and the exact example on the review was a fence that is 20 meters long. So we've got something that is this 20 meters long. It's going to form a rectangle, and we want to find the maximum area. So let's see what we've got. It's a rectangle. So whatever the width is on one side, it has to be the same on the other. And whatever the length is on one side, it has to be the same on the other. And we can see that 2W plus 2L will be equal to the distance around the perimeter. But that's going to be our 20 feet, or 20 meters. So let's take the extremes here and factor out a 2. We've got 2 times W plus L is equal to 2 times 10. And let's divide both sides by 2 so that we have W plus L equals 10. Well, I need to have a way to talk about the width and the length separately. So let's let X be the width. So we're going to substitute X in this equation. That means that X plus L equals 10, or getting L by itself, L is equal to negative X plus 10. So now we have a length and a width, and both in terms of X. And let's go back up here. We're looking for the maximum area. Well, let's write the statement for the area. Area for a rectangle is length times width. The length was negative X plus 10. The width was X. So we get negative X squared plus 10X is the formula for, or the function for, the area, where X is the width. But now I see that this is a quadratic. And since it's a quadratic, I know that the maximum or the minimum occurs at the vertex. Well, let's look at the value of A. Here it is. A is equal to negative 1. So we will have a maximum at the vertex. So we just have to find the vertex. I know that the X coordinate of the vertex is negative B divided by 2A. Let's see, B is 10. So negative 10 divided by 2 times A is negative 1. That's negative 10 divided by negative 2, which is positive 5. This is the width that will give the largest area. So let's substitute this value into the area function and see what area results. So A of 5 is negative 5 squared plus 10 times 5. And that's negative 25 plus 50, which is indeed 25 meters squared. And what's cool is that you actually can find, without using calculus, that the kind of rectangle that produces the largest area for a constrained dimension around is a square. So because we got the width to be 5, we said that the length was negative the width plus 10, so negative 5 plus 10, and that is also 5. So if the length and the width are the same, we have a square. So the answers are actually 3. There are 3 answers to this one. 25 meters squared is the maximum area, and the length and the width that give us that are 5 meters and 5 meters.